A function is called continuous if the value at a given point is same as the value of the function when the function approaches that point. For example, if x is 3 and this is your graph, and let's say at 3 this value here is 5. See what happens. The function at 3, the value is 5. Right before 3, right before the function becomes 3, let's say it's 2.99999, almost 3, but less than 3. The value is still here. It's still almost 5. So they are the same. At 3 and before 3, the function is approaching 5. And right after 5, right after 3, the value is still here. It's at 3.000001 or something even smaller. The function is still close to 5. So at all three situations, the function is giving you the same value, 5. In this case, the graph is continuous. If you look at the nature of the graph, it keeps going without any break. So the graph is continuous at 5. In this situation, if we have this and this, if this is 3, let's say this is 5 and this is 8, right before the function becomes 3, the value is right here. It's 5. So right before 3, the function is 5. At 3, the function is here, which is 8. And right after 3, the function is still here after 3, which is 8. Now in this case, before 3 is 5, at 3 is 8, and after 3 is 8. All three numbers are not the same, so the function will not be continuous at 3. Now let's work on our example. We have a function that's changing its definition at 2. We look for the point where the function is changing its definition. Before 2, function is x squared plus 1, and after 2, it's 2x plus 1. We'll find the value of the function at 2. Now, when x is bigger than or equal to 2, it's defined as 2x plus 1. So it would be 2 times 2x, x is 2, plus 1, which is 5. Now, find the value of the function just before 2, and we write it as 2 minus, just before the function becomes 2. So right before 2, the function is given by x squared plus 1. You plug in x for 2, it becomes 2 squared plus 1, which is 4 plus 1, 5. And finally, find the value of the function when it's after 2, right after it has become 2. In this case, x bigger than 2 is defined as this. So in this function, we plug in x for 2, 2 times 2 plus 1. Notice that these three values are the same. And if that's the case, you can say that the function is continuous at 2. And if it's continuous at 2, these two are continuous functions already. This 2 was the only exceptional point. And if it's continuous at 2, we can say that the function is continuous everywhere. So the statement would be fx is a continuous function.